Okay, so this first one, you pull the force at 320 newtons and the angle is 20 degrees above the horizon. What you can do is you make a right triangle for each of these. For instance, out of this 320 newtons, part of that force acts horizontally, we'll say in the x direction. Part of it you're pulling up in the y direction. And so to find the adjacent and opposite sides, do you remember what functions you might use to find different sides knowing the angle? SOHCAHTOA, right? Remember that? SOH, CAH, TOA. And what that is a quick reference. It's an acronym for how you know when to use sine, cosine, tangent. Which one do we use if we look for the adjacent side knowing the hypotenuse?
Cosine.
Yep, because the force in the x direction, right here, is going to be that 320 newtons cosine 20 degrees. What about the force in the y direction? How do we find the opposite side if we know the hypotenuse? Sine. 320 newtons sine of 20 degrees. Now also in your calculator you want to make sure it's in degrees. If the angle is given to you, if you have a question in degrees, your calculator should be in degrees, you're going to get some funny answers if you're in radians. But when you do this, you get like 300.9 or something like that. Well, the two significant digits, you might see it as 3.0 times 10 to the second. You don't have to write it like that, but like for instance, if this were multiple choice, you would probably have it in correct number of scientific notation, correct number of significant digits. So that's 300, it's the same thing. Just like the force in the y direction is about 109 newtons. You might see that as 1.1 times 10 to the second newtons. So we just found the force in the x and y directions. And what that actually means is even though you're pulling up at an angle of 320 newtons, horizontally, you're pulling the object 300 newtons horizontally, and vertically, at the same time, you're pulling up with a force of about 110 newtons. The second one about the lawnmower. Same idea, but this time the force is exerted down. You've got 90 newtons acting down at an angle of 25 degrees. So again, we can find that force down in the y direction, the force in the x direction. The force in the x direction will again be used to cosine, because anytime you measure the angle with the horizontal, the adjacent side is the force in the x direction. So I'm going to do 90 newtons, that's the hypotenuse, cosine the angle of 25 degrees. Force in the y direction is 90 newtons, sine of 25 degrees. So your force in the x direction, if you get 81.57, that's approximately 82 newtons. And the force in the y direction, I got about 38 newtons. And if you consider up to be positive and down to be negative, you're pushing down. This could be negative 38 newtons, or because you have the picture which already illustrates the direction of the force, it's not as important to have a negative. Whether you have negative or not, it doesn't make a difference if you have a picture that already indicates the direction because force is a vector. All right. Now, how does that force, how does this change the normal force? Both questions ask about the normal force. The normal force is the force exerted between the object and the surface. So if you're pulling up on this, the first one, if you're pulling up on the box as you're pulling it along, do you think there's more or less force between the box and the floor? If you're pulling up on it, there's more or less force. There's less. Its weight doesn't exert as much force on the floor because part of its weight is being taken away because you're pulling up on it. So the normal force is actually less when you pull up on something. So what do you think about the normal force if you're pushing down, like on the lawnmower? The normal force will be greater, more, it'll increase. Think about it this way. Here's a book that's sitting on this table. It's not moving because the weight down and normal force up cancel each other out. The normal force could be different, however. If I start pushing it across the table here, but I'm pushing down on it like this, I'm exerting more force down on the book, which means I'm pushing it into the surface, which means the force of the surface back on the book increased, because I'm pushing down on it. If I pulled up on it, though, there's less force between the surface and the book. All right. Give you a chance to, just a few minutes to read this one over and see if you can draw a free body diagram and indicate the force in the x and y direction.